you're in the creek. This is Zanja Dakota Creek on the reservation, and we are collecting stream flow measurements. So right here we have a wading rod. This is a 4-foot wading rod. This is our velocity meter. And what we're taking is velocity measurements of the creek, flow measurements as part of our monthly water quality monitoring, along with our samples that we collected and our in-stream physical measurements, pH and temperature, dissolved oxygen, turbidity, and then stream flow is the last one that we do. So what we're doing is taking velocity measurements at intervals across the width of the stream. And then what we do is we add them all together to get a full stream flow measurement for this section of the creek. So I move the wading rod, I place it flat on the bottom of the creek. I look at my depth on the wading rod, it is 0.2. And then I hold the probe, the sensor is still as I can so it can get accurate velocity readings.
You can kind of see the water.
Kind of see the water.
Gosh. 25.37. Putting gloves on just so that we don't contaminate.
Cross-contaminate anything. We have basically 2 different tests and we have 2 different samples we're going to do. So that's why we have 4 bottles. And what we're going to do is actually take just a little bit out of each of these samples to put into these. So we're going to do 10 milliliters of the sample. This is ZDC7, not the replicate. Little filter can.
I can fill this up.
Oh yeah. And then we fill the rest of the sample with just regular distilled water. I'm gonna fix my little... These little packets are basically like a reagent, and there's like, it's like a food for the microorganisms, for the bacteria. And so what we do is we mix it with the water, and then we put them in we swirl it around and make sure it's mixed up good. We put it into the trays. The less air bubbles you have in each of the cells, the better. You see there's some air bubbles, but let's give them a little flick. Our duplicate and our regular sample come out like vastly different, you know that you're probably like, maybe you cross-contaminated something. So you want to make sure your duplicate and your sample come out pretty similar, within a similar range. We have this very nice quantity tray sealer, and you put each of the trays into this little rubber mold, and you slide them in, and it will kind of heat seal them and close them up. That way they're ready for the incubators.
For any of the cells that fluoresce, that's an indicator for E. coli. So that's what the mark the other way is. That's why it looks like an X, is that it has both yellow and it fluoresces. Alright, so now that we've taken our soil samples, what we're going to do is fill these jars almost all the way up with water. I'm going to add a little dash of dish soap. This will separate out the different soil particles. Give it all a good shake. Different parts of the soil have separated out. So what we're going to do is we're going to measure the total amount of soil, and then we're going to mark where the sand, silt, and clay has separated out, and we're going to find out what the percentages of that is, and that'll tell us what kind of soil we have. Here they all intersect at loamy sand.